Hi everyone, how are y'all? So my name is Shashipal and welcome to my channel Shashipal Mathswala. Till the previous video, we have discussed some of the questions regarding the some of the concepts that we have discussed already from the beginning of the chapter properties of triangle. Okay? Till the concepts which we have discussed regarding that I have covered huge number of applications. It means huge number of questions. You can check those videos. I have given in the description box. Okay. In this video, we are going to discuss some of the concepts regarding the triangles related to circles. So today's concept is circles related to triangles. Okay. It means we are going to study some of the relations regarding the triangle which are connected to the circles. Okay. Basically, in general, for a triangle, there are basically two types of circles that we can draw on it. One is the circle which lies inside the triangle, and the second is which lies outside the triangle. Okay, this is the triangle, and this is how we can draw the two major types of circles, that is the circle which lies inside the triangle and the circle which lies outside the triangle. Okay, basically these two types we are going to discuss in this video and in further videos also. For a, for a triangle, let me consider triangle A, B, C. A circle can be drawn inside the triangle ABC so that these sides AC, AB, BC act like tangents to the circle. Okay? Basically, this type of circle is called as incircle. The circle that is drawn inside the triangle, in which the sides of the triangle act like tangents to the circle. Okay? The circle in which the circle drawn inside the triangle, in which sides act as tangents to the circle. This is what we have to understand. A circle drawn inside the triangle so that these sides act as tangents to this circle. Such type of circle is called as incircle. Okay? This is one type. And the second type is, let me consider triangle ABC. No, not ABC, any triangle. There can be a circle drawn which lies outside the triangle. Here we can see that this is the circle which is passing through the three vertices of the triangle, right? And the sides of the triangle act like a chords, right? Such this type of circle is called a circumcircle. circumcircle is nothing but it is the circle drawn on the triangle outside the triangle so that it passes through the vertices of the triangle and the sides of the triangle act like a chords. Okay, this type of circle is called as circumcircle. Let me write the definition. The circle drawn outside the triangle passing through vertices and sides act like chords. Such type of circle is called as a circumcircle. Okay. In regarding the concept of incircle, the radius of this incircle is denoted with small r. Okay. And the radius of the circumcircle which is outside the triangle is denoted with capital R. Okay. Let's move on further. And here is another thing that you have to understand, that the radius of the incircle is called as in radius. The radius of the incircle is called as in radius, and the radius of the circumcircle is called as circumradius. The radius of the circumcircle is nothing but circumradius. This is what the basic term you need to understand. Incircle, incircle, in radius, circumcircle, circumradius. Incircle is nothing but the circle drawn inside the triangle so that the sides of the triangle act as tangents. Circumcircle is nothing but the circle drawn outside the triangle so that it passes through the three vertices of the triangle and these sides act like chords. Okay. And the radius of the incircle is nothing but in radius, and the radius of the circumcircle is nothing but circumradius, which is denoted with capital R. In radius is denoted with small r and it is denoted with capital R. This is what the basic terms and meanings you have to understand. Let's move on further. So first of all, we try to understand about these two type of circles and their major results, and then we will move on further concepts. The first one is incircle. In this video, we are going to discuss only about incircle, its meaning and its results. Okay. Let me consider triangle ABC. Let me consider triangle ABC. Let me draw a circle inside the triangle. As I said, the sides of the triangle act like a tangents, and this is the center of the incircle. Okay. For when I join the point of intersection of the tangent and the boundary of the circle, these are perpendicular to the. It can be understood that these are perpendicular to the sides of triangle, right? It's nothing but radius of the incircle. Okay. And for a triangle, when two tangents are drawn from a point, its length and its length are going to be equal. And when I join the center and this point, this angle and this angle is going to be equal. It means this line is going to act like this line is going to act like a angular bisector, right? Similarly, let me join the vertex and the incircle. This point is denoted with I. Incircle center is denoted with I. Okay. Let me join the vertex and the center of the circle. It means it is going to be A by 2. It is going to be A by 2. It is going to be B by 2. It is going to be B by 2. It is going to be C by 2. It is going to be C by 2. It's not exactly that it's a straight line. It's not a straight line. Let me put it as A dash, B dash, and A to C dash. A dash is not a line. It's not a continuous straight line. AI is a one line and IA dash is another line. Okay? Now, let's discuss some of the results related to the triangle and the incircle. Suppose let me consider area of the triangle. Delta is nothing but area of triangle ABC. Right? It can be written as area of triangle AIB plus area of triangle BIC plus area of triangle CIA. Area of triangle ABC. Area of triangle ABC is nothing but area of triangle AIB plus area of triangle BIC, area of this part plus area of this part plus area of triangle CIA, area of this part. Area of triangle ABC is nothing but this whole part area is nothing but area of this part plus area of this part plus area of this part. Adding the area of these three triangles, we are going to get that area of total triangle ABC. Okay? That is equal to AIB. AIB. It is perpendicular or base is nothing but C. It's A and it's B. Okay? So, area of triangle AIB is nothing but half into R into C. Base is half in area of triangle AIB, half into base into height plus half BIC. AR plus half BR. Okay, let me take R by 2 as common. A plus B plus C. Instead of R by 2, it can be written as R of A plus B plus C by 2. Right? It means area of triangle is nothing but area of the incircle into circumcenter. It means radius of the incircle is equal to area of the triangle by semi-perimeter. This is the most important result that you have to remember. And this is how we can derive. I have considered this triangle as three parts. This part, and this part. Here we have perpendicular and a base. For this perpendicular, base. For this perpendicular, base. Perpendicular is nothing but height. Half for this triangle, half into base into height. Half RC. Half into for this part, half BIC, half into base into height, half AR. Area of triangle AIC, half into base into height, half BR. After further simplification, A plus B plus C by 2 is nothing but semi-perimeter. So radius of the incircle is nothing but area of the triangle by semi-perimeter. And this is how we can derive it. This is the important formula that you have to remember in solving many problems. Okay, let's move on further. We have already derived radius of the incircle is nothing but delta by s, right? So delta is nothing but area of triangle, right? It's nothing but root s of s minus a into s minus b into s minus c by s, right? And this can be written as root s minus a into s minus b into s minus c by s. It means radius of the incircle is nothing but delta by s, area of the triangle by semiperimeter. It can also be written as root s minus a into s minus b into s minus c by s. Actually, this part is important, but I have written this also because by this I am going to derive the other form of radius of the incircle. This is the first form of radius of incircle, and I am going to derive the other form of radius of incircle. Let's move on further. R is equal to root s minus a into s minus b into s minus c by s. This is what we got after simplifying the formula. Radius of the incircle is nothing but delta by s. Right? Now, what I am going to do is, let me multiply on numerator and denominator with s minus a, so that I am going to get s minus a whole square into s minus b into s minus c by s of s minus a. Okay, let me take s minus a whole square out, so that I am going to get s minus a into root s minus b into s minus c by s of s minus a. Root s minus b into s minus c by s of s minus a. This part shows us the short form of r is equal to s minus a into tan a by 2. Right? Radius of incircle is equal to s minus a into tan a by 2. Before this, I have said that I am going to prove the other form of radius of incircle by using r is equal to delta a by s. This is the other form. Not only this, if I'm let me write it as I root s minus a into tan a by 2, and and next in for this, what I have done, I have multiplied on numerator and denominator with s minus a, right? So that I got s minus a whole square, I taken it out. In second case, what I am going to do is, instead of multiplying with s minus a, let me multiply with s minus b, so that I am going to get s minus a whole square, s minus a into s minus b whole square into s minus c by s of s minus b. Let me take s minus b whole square out, so that finally I am going to get, instead of s minus a, s minus b into s minus a into s minus c by s of s minus b. Root s minus a into s minus c by s of s minus b. It is showing us the direct form of tan b by 2. It's nothing but s minus b into tan b by 2. S minus b same, and this part can be written as tan b by 2. Similarly, if I in first for this I have multiplied on numerator and denominator with s minus a. For this I have multiplied with s minus b, and in other case I am going to multiply with s minus c, so that I am going to get s minus a into s minus b into s minus c whole square by s of s minus c. And next, what I am going to do is, let me take s minus c whole square out, and finally I will get s minus a into s minus b by s of s minus c. This whole part, it shows us the direct form of tan c by 2. If I write it aside, is equal to s minus c into tan c by 2. Okay. Radius of the incircle is nothing but delta by s. By using the same formula, I have derived these three results also. Radius of the incircle s minus c into tan m by 2, s minus b into tan b by 2, s minus c into tan c by 2, where s is the semi-perimeter, s equal to a plus b plus c by 2. Okay. Now, so that's it for this video, and for some further results and further concepts, I'll meet you in the next video. Until then, tata.